This is the Zoom for heavy civil construction, Monday, May 4th. We're starting around 7:30, a little bit early. We just finished up construction surveying. One of the things we were talking about was the fact that soil A sieve analysis and graph was graded. Soil B will be graded tonight. The answer key will be posted. The answer key for soil A has been posted, so you can go through and look at that. And just grabbing my checklist here for the new course. And then the homework is the classification of soil A and soil B samples, same ones that you did the sieve data sheet and the graph for. You're now going to classify according to the USC chart, Uniform Soil Classification Chart, that is on the Excel, which is attached to Vanco. We went over this last week, last Thursday's Zoom. So to learn how to do that again, you can go back to last Thursday's Zoom, which is on YouTube. And I go through this step by step. And as I just mentioned, sorry to say this again, but both soil A and soil B are going to be coarse-grained soils. I'll tell you right now that if you were out in Denver and you had a soil that had like 65% passing the number 200 sieve, in other words, out of 100 pounds of a soil sample, 65 pounds would be silt and clay. That would be a fine-grained soils because greater than 50% past the 200. So that kicks in this part of the chart. And then you got to look at something called the liquid limit, which is the moisture content that makes soil go from a solid to a liquid. In other words, it looks like flowing lava, like that marine clay slide in Norway. So you will be using these over here. You're going to get the soil symbols as best you can. And you're going to go from here all the way down to here and give me the soil symbol. And it'll work you right through this, okay? So you got to show, if you can print that and then write down your data and highlight each step. You know, are you a sand or a gravel? And so on. That's the best. If you don't have that capability, you don't have to copy the whole thing. You just got to copy, say, for each step, the information that is related to your soil information. Okay, so do you want that due Wednesday night at 11:59, or do you want that due Thursday at 12 noon?
11:59.
Wednesday night works for you?
Sounds good.
Does anybody need it till Thursday? No, so that's 5, 6.
I mean, I don't see why not.
Well, okay, I'll give you till Thursday. So what day is that? That is the 7th?
Wait, what's due Thursday?
The soil classification. So you'll get an extra 12 hours. And I'll put this on Vanco. You're going to have to classify soil A and B according to this chart. And this chart is in your Excel on Vanco Hall. So we're going to do Thursday, today's the 4th, so it's Thursday 5/7 at 12 noon. Okay? Thursday 5/7 at 12 noon. Okay. So now what we're going to do is we have discussed running the sieve test, which is a grain size analysis test. Along with a hydrometer, we just touched on that just a little bit, which gives you the percentages of silts and clays. We then classified the soil, right? And right here is where you go to your project specs to see if you can use the soil you have classified. So I may give you a copy of a soil spec and give you the symbol, and you have to tell me whether or not it's a satisfactory or unsatisfactory soil. In other words, does the contract, the construction contract specifications allow a certain type of soil? So that's why you run a grain size analysis test or a sieve test. That's why you classify it. Right? If you're doing a pond, you don't want gravel. It's not going to hold water. If you're doing a road base, you don't want clay. You want a good clean gravel. So once you classify it, and once you have your source of engineered soil or engineered fill, then you have to check what the compaction requirements are going to be. And so that I would have you go back to, I got to move this little bugger again as usual. I know it's on the PDF. So if you go back to, this handout, okay, this was off the web, right? We talked about soil testing. Once we have established that a soil is satisfactory according to the specifications, then we got to check some laboratory testing before we can compact it out in the field. So compacted soil is measured in terms of density in pounds per cubic foot. Okay, so you want to read these next couple of pages over again, pages 11 and 12. So to determine the density value of a soil, and again, density is the same as unit weight. Density value of a soil from a given job site, a sample of the soil is taken to a test lab and a Proctor test is performed. So the Proctor test is a lab test. It is predominantly a lab test. And that's the Proctor mold right there. So the purpose of the Proctor test is twofold. It measures and expresses the density attainable for any given soil as a standard. And here's the biggie. It determines the effect of moisture on soil density. So what it is a relationship between density and moisture content. Okay. So you basically fill this mold. This is a standard Proctor. They also have what's known as a modified Proctor. For the standard Proctor, and you can see it right here, there's 3 lifts. You put this in 3 layers in this mold. This is the collar, so that eventually you can take the collar off, you trim off soil, and you put it in 3 lifts and you beat it with this thing. It's like a little hammer. You hammer it 25 times, kind of like running a slump test. The volume of the Proctor mold is 1/30th of a cubic foot. In other words, how many of these would it take to make 1 cubic foot? If one of those is 1/30th of a cubic foot.
30.
30. And if you remember that, it's going to make the math easy on a test. Now, I'm thinking, and we have a Zoom on Thursday night with this course at 6:30. We'll Zoom again for Heavy Civil Thursday at 6:30. I'm thinking of giving you that final, and it's just a soils test. It's not a comprehensive final. So it's actually test number 3 a week from this Wednesday. So you'd have a surveying test Monday night, and you'd have the Heavy Civil test Wednesday night. So think about that. We will make a final decision at our Thursday Zoom. Site test date. Okay, so we're going to show you a little of YouTube, and eventually you're going to make about 5 or 6 samples of soil with increasing amounts of moisture for each soil. So imagine taking a Ziploc bag, filling the Ziploc bag with dirt, fill 6 of them. And then in the first one, you add just a little bit of water. To the second one, you add some more, third more, and so on. So now you have 6 samples with a wide range of moisture. And then you put them in the mold and beat the living hell out of them with this Proctor hammer. And then you're going to weigh the soil in the mold. You're going to take a sample of each of the 6 samples. You're going to get its weight in the mold, and you're going to get its moisture content. And eventually, you're going to graph density versus moisture. So this is increasing density on the y-axis, increasing moisture content on the x-axis. And this is called the Proctor curve. And it's going to look like a bell-shaped curve. And at the top of the curve is your maximum density and your optimum moisture content. And optimum means best. And here they talk about the behavior of soil. Soil behaves very differently. And therefore, each type of soil will have its own unique control curve, its own unique Proctor curve. You can get more than 100% Proctor. We'll talk about that down the road. Again, the modified Proctor uses a 10-pound hammer, the standard Proctor a 5.5 pound. The modified Proctor drops 18 inches, the standard Proctor drops 12 inches. So let's, we're going to show you a YouTube. Now I got to find where the hell did I put it? Watch from Monday Zoom. That would be us. And let's go to here. Maybe not. Let's see, how's my, still got Wi-Fi. Resume recording.
With the Missouri S&T Geotechnical Labs. Today we will be going over the laboratory procedures used for a standard Proctor compaction test. This short video will demonstrate how to conduct a standard Proctor compaction test in accordance with ASTM specifications. This test was developed to evaluate the level of compaction of field compacted soils. The soil is compacted into a mold at a specific energy comparable to the energy used in the field. The laboratory Proctor test is performed at varying moisture contents to establish a dry density versus moisture content plot. From this plot, the maximum dry unit weight and optimum moisture content can be determined. The practical application of this test in geotechnical engineering is for compacted specification of soils. The maximum dry unit weight obtained from this test can be used to determine the relative compaction of soils in the field. The equipment required for the standard Proctor compaction test is a 4-inch mold having a volume of 1/30th of a cubic foot and a collar, a standard Proctor compaction hammer weighing 5.5 pounds and dropping 12 inches, 2 moisture content cans, a steel straight edge, a large mixing pan, a graduating cylinder capable of holding up to 250 milliliters, a spray bottle, a metal spoon, and a knife. We'll also be needing a digital balance, an oven for moisture content determination, and a sample extractor. The soil that we will be performing the standard Proctor compaction test on is a loessile silt obtained from the Mississippi River Valley. The soil has been mechanically pulverized, then air dried. The lab documents pertaining to today's lab can be found on Blackboard. The handout is posted there and is titled CE 215, Laboratory Number 5, Proctor Compaction Testing. In addition, an ASTM standard pertaining to this lab is also posted. ASTM D4698 pertains to Proctor compaction testing. Also available is today's data sheet. The Proctor compaction test consists of mixing soil with water to a predetermined moisture content. This soil-water mixture is then compacted into a mold of a specific volume with a standardized energy. At low moisture contents, interparticle friction will hinder compaction, resulting in a low unit weight. As moisture increases, the friction in between the particle reduces, and the particles will compact into a more dense pattern. At past a certain moisture content, known as the optimum moisture content, water will start to take the place of dry soil particles, and the dry unit weight will again go down. By conducting several standard Proctor tests at varying moisture contents.
Can you guys hear me?
Yes.
That's the wrong curve. That's the one from the sieve curve. So they goofed. Just saying. So we'll speed it up a little bit here. So what he's doing right now, he's weighing it.
Record the empty weight on your data sheet.
And while he's weighing it, let me go to an Excel that, remember we were just looking at, it's the same Excel that had the sieve analysis. Now it has the Proctor for you. Okay? It has the Proctor for you. These little buggers are always in the way. Here's actually another one where everything was in grams, but that's for you to use. This is going to be a homework assignment, this one. It is not due before next Zoom, because we're going to talk more about this on Thursday night. So the only thing you got to do for homework is that classification, okay? There's about 5 deer right in the side yard. There's dinner. Just kidding. Now, so what he's doing is he's going to enter data in a data sheet. The mold is weighed. It's 1/30th. If you'll notice, this has got to be, and I'm gonna update this for you. Okay, so the volume of the mold is 1/30th of a cubic foot. He weighs the mold 9.45 grams or pounds. And then the weight of the mold is right here. Okay, so we're going to follow these along, and then we're going to discuss it even more on Thursday. So where the hell is that YouTube? Okay.
Also weigh the 2 moisture content cups and record their weights as well.
And that data is right here under the moisture content determination, what I call the cat food cans. The tear is the can, okay? So we call that, I will just write it out, cat food can, because that's what I use. Okay? So he's weighing that out. And
with a caliper, record the dimensions of the mold so the volume can be calculated.
we're going to say it's 1/30th of a cubic foot, so I'm not worried about
An
that.
accurate measurement of volume can be established. Must be determined.
So now he's going to go.
The weight of the water that needs to be.
I'll show you my own calcs.
Moisture content.
My calcs are easier. So now he's going to add some water
Using the spray bottle,
to the
add the water
to
to
the
the
sample.
soil and start mixing it till it becomes a uniform color and consistency. When all the water is gone and the soil has been mixed to an even and uniform consistency, it is time to place the soil in the Proctor compaction mold. Start by placing the collar back on the Proctor mold. Spoon enough soil into the mold that when compacted, the soil mold will be filled approximately 1/3 of the height of the mold. Now you want to place the mold on a hard surface such as a concrete floor and compact with the Proctor hammer. Compact the soil using the standard Proctor hammer. Use 25 blows spaced evenly throughout the layer for proper compaction.
It's got like a rhythm to
After
it.
25 blows, take the mold back to the table, scarify the surface, and add more soil for the next lift. Scarify the surface of the first compacted layer with a spoon. This will ensure that the second layer will bind to the first layer well. Spoon enough soil into the mold so that when compacted, approximately 2/3 of the height of the mold will be filled.
Again, with the standard Proctor, it's three layers. Modified is 5. You're going to run this test in the lab.
Again, take the mold to the concrete floor and compact it with the standard Proctor hammer. The soil should fill the mold and extend past the top of the mold.
That's after his 3rd lift.
Using the straight edge, trim smooth the top of the soil mold. Using the leftover material, fill any voids that might appear in the surface of the soil. Remove all the loose soil around the mold and weigh the mold without the collar. Loosen the soil mold from the base.
So when he weighed it,
I could be wrong, but I think there's somebody in the waiting room.
it didn't come up. Where is it here? New share, that's manage participants. No? No, I don't think so.
Gotcha, sorry.
Probably a Russian spy. Anyway, communist spy, sorry. Better get that right. So what he did here is he weighed the mold empty, and this is what it weighed after it's full. So this is a combined weight. You subtract the weight of the mold, and that's the weight of just the soil in the Proctor mold. But how many of those molds did it take to make 1 cubic foot? 30, because each mold is 1/30 of a cubic foot. It's almost like that concrete density test that you did, where the air bucket is 1/4 of a cubic foot, right? So you got the net weight of concrete, dividing by 1/4 is the same as multiplying by 4. Here, dividing by 1/30 is the same as multiplying by 30. So take a look at this. This is called the wet unit weight. And it's the previous, it's this cell times 30, and that's your wet unit weight. We'll talk a little bit about dry unit weight tonight, but a lot more on Thursday. Okay, so what he's going to do is, as he takes that sample out of the mold, he's going to capture some of it and put it in that cat food can and weigh it immediately. Why does he have to weigh it immediately? Because the moisture is going to evaporate and it'll throw off his data. So he weighs it immediately, just a little sample of the soil from that mold. And what does he do? He puts it in the oven, and this is what it weighs after it's dry. And don't forget, he does like 5 or 6 of these samples, and each sample has an increased moisture content, and then that's what's going to create the bell curve, which is what you see over here for the other example. Okay? So what he's doing now is he's weighing it with the soil, and then he'll get his net weight. And we call this
Two hands
puck.
carry the soil in the mold into the extractor and extract the soil from the mold. Insert the soil and mold into the extruder.
This is kind of cool. We actually use that. We have something similar, and we use that, I call it that soil hockey puck, and we freeze it, and that is our frozen soil sample for mix and strengths of materials course.
And carried it into the other room. After the sample has been extruded, split the sample with your knife. Take samples from the top and the bottom and place them in the moisture cans for moisture content determination. Weigh the cans on the scale and record the weights.
Now we're only going to do
Cans in the
one.
oven.
He's doing 2 for each sample, each Ziploc bag of soil
24 hours
to get an
remove
average.
the cans and record the dry weights. The dry unit weight of the compacted soil specimen and the moisture content can be calculated. From several iterations of this test, a plot of the dry unit weight versus moisture content can be determined. From this plot, the maximum dry unit weight and corresponding optimum moisture content can be determined.
So, what I want you to do is take a look at that video again by Thursday. And there are some, let me go back to the Excel. Right? So that was, and again, we're only doing 1 cat food can for each Ziploc bag of soil. Each Ziploc bag has different moisture in it, different amounts of moisture. So the difference between the dry soil after shake and bake in the oven and what it weighed wet is the weight of the water. Okay? And the weight of the water divided by the weight of the dry soil, the weight of the dry soil is the weight of the dry soil plus the cat food can minus the weight of the cat food can. And it's 31.9%. Now this is a clay soil. It's going to have a very high moisture content. This is a gravel over here, a gravel or a sand, and it has very low moisture contents. Again, I'm going to update this for you by Thursday, and we'll review this again. So here are the handouts that are going to help you understand this. These are on Vanco now. So let's go back and show you where on Vanco it is. So, Proctor Nuke compaction. This week, 4th of May to the 10th of May. the lab packet soils, the Denver case study, which we will cover extensively Thursday night, and the soils handout, number 4 for the proctor. So I've got 2 out of these 3. I've got this one and this one up on PDF. So let's take a look at it. So this is soil handout number 4. And the first page, can't remember. Yeah, the first page is my understanding of the proctor test, okay? They also, like I said, do a very good job with the web soil handout that we talked about earlier. So read this, and it talks about what do we do with the proctor curve, the laboratory proctor test, right? After we're done running that proctor test. And this is what I'm talking about here. Don't bother with the exercises, but there's that bell-shaped curve. There's the bell-shaped curve. Oh, and there is also another, I'm going to have you watch another YouTube for Thursday, and I'll post that to Vanco. And probably the most important paragraph is right here. The Denver handout gives a really good example of this, which we'll go over on Thursday. But the specified compaction for soil at the construction site is expressed as a percentage of the maximum density obtained from the proctor test. In other words, the spec might say, we want 95% of the maximum density that you got in the lab for the soil at the site. Or a better way of wording it is, the density of the soil at the site has to be 95% of the top of that bell curve that you got in the lab. I would say read this about 5 times. Actually, read it twice, put it down, and read it again. This is a big part of the test, and it's a huge part of the field work that you're going to do. Because one thing we are going to be able to do is when you come back, we're going to be able to bring some folks in from industry to show you the nuclear density machine that will tell you what the density and moisture is of the soil at the site. And then we have to compare it to the proctor curve, okay? So read that first page. This is just another example of a proctor curve. Here's actually the homework that this is what I put on Excel, this right here. So that is not due Thursday. It will be due, probably Saturday or Sunday after we talk more about it on Thursday. So this example right here, I put on Excel. So you're going to be able to get the correct answers. You're just going to have to show me the calculations for 1 or 2 of these data points. Again, there's 6 samples of soil, each with increasing amount of moisture. And there's the curve that you're going to have to plot the curve by hand, so you can use that. We'll talk about that on Thursday as well. So you got 2 curves that you can use. If you can't make a copy of that, don't worry about it. Make your own copy. Get lined paper and then just draw some vertical lines. You'll be able to, I'll show you how to graph it on Thursday. So you want to read that. The lab packet soils, okay? This is what you're going to get when you come back and you're going to run 3 soil tests: sieve test, proctor test, and in-place density test using a sand cone. Here's some information here. Oh, where the hell did it go? Oh, on page 7, here's all the calcs on how to do the proctor curve. So on page 7, again, this handout is the lab packet. And just to review, right, it's in this week's Banco Hall, and it's under lab packet. So page 7, calcs, page 7. I'm just writing myself a note. Okay, we just looked at the handout number 4 in the proctor. Okay. And that, like I said, this tells you that the dry density is the wet density divided by 1 plus the moisture content. So you remember the data points that we had on the Excel. The wet density was 105.9, the moisture content was 31.9. Let's take a look at that again. Right, 105.9, 31.9. And you don't have to memorize this formula. It will be on the test. But you have the wet density divided by 1 plus the moisture. But the moisture content has to be in decimal form. And so there's your dry density. And that's what you plot versus moisture. You plot dry density versus moisture content. So you want to read those. And also, like I said, take a look at that YouTube. And then what we're going to do, we'll go over some more of the calcs the first part of Thursday, Zoom, and then we'll analyze the Denver handout, which talks about analyzing field data. Okay, we're going to analyze field data as it relates to the lab proctor data. And let's see. And then we're gonna get some specifications, and we're gonna kind of highlight those and show you where it's written that a soil is satisfactory or unsatisfactory, or it has to meet 95% of the maximum dry density from the proctor, or 98%. So we'll get you acclimated to the specifications as well. And then we'll run the test when you get back. It's a lot of fun. Like I said, that and pizza, it'll be good. Okay. So that gives you a good start on the proctor test, test number 2. And we'll meet again for Zoom this Thursday night on HeavyCivil to talk more about soils. And again, think about, I'm looking at probably Wednesday, the 13th, Wednesday night from between 6 and 10, give you a 2-hour block to do a soils test. It'll just be on soils. Okay. Any questions? Okay, I think I put you to sleep on this one too. So I got that going for me, which is nice. So look over those YouTubes, do a little bit of reading. You have the Excel, you can take a look at it. I'll update it, but you can take a look at the proctor, and make sure you get that homework to me by Thursday at 12. Give me something. You got to show me the steps, just like I did it on last Thursday's Zoom. So that ends our Zoom. Again, we hope all is well for you and your families. And I'm going to stop recording, and then I will put this on YouTube.